So carrying on with the science session, our next talk is from Sopow at Scion here in Rotorua, who's the entomologist at Scion and also heads the diagnostics in forest pathology. But Steph is leading a project for a biocontrol on the giant willow aphid. So I'll hand it over to Steph.
Good afternoon. I'm really pleased that today I can tell you that we're wrapping up a 3-year project on management of giant willow aphid in the next couple of days. So we set out as part of this project to identify potential options for long-term and sustainable management of this destructive pest. At Scion, we've been focusing on biological control. So what we've done is identified a possible candidate. We've brought it here to our containment facility for testing. Our testing's gone very, very well, and we've put together an application to the Environmental Protection Authority for its release. We've also been working in tandem with plant and food research, and Trevor Jones, who you'll be hearing from later in this session, will talk about that. They're looking at willow resistance and also quantifying the damage that the aphid causes to willows. So I've got 3 main messages for you. The first is that giant willow aphid is bad news. It's causing real problems in New Zealand. Second is that this parasitoid that we've identified from California looks really promising. And lastly, we need your help. So it's not enough that we can demonstrate that this looks very safe to release in New Zealand and won't harm any other organisms here. We also need to show that New Zealand is behind us and supports this. So briefly, I'll go over the biology of giant willow aphid, or GWA as we call it. We're not sure exactly where it's from, somewhere in the northern hemisphere. Its hosts are willows and poplars, but in New Zealand we find it sometimes on apples and pears as well. It feeds on plant sap and secretes honeydew, like all aphids, but there are a number of features that set it apart from other aphids. One is its size. It comes in at a whopping 6 millimeters when fully grown. That's big for an aphid. It's got this conspicuous kind of shark's fin on the back that you can see in profile. We don't know what that's for. Only females have ever been found, so all reproduction is by parthenogenesis. And this happens by live birth, not by egg laying. So there's an image here by Shiny Beetle Man that I found online of a giant willow aphid giving live birth. Under ideal conditions, they can give rise to about 4 offspring per day and about 70 in total in their lifetime. And their lifetime is generally fairly long-lived for an aphid, so about a month in summer and up to 3 months when temperatures cool down. They don't seem to mind the cold very much at all. They persist well into winter. It's the springtime when they can become really difficult to find, and we're not sure what they're up to in the spring when we can't find them. So there's a few mysteries surrounding this aphid. So I'm going to try really briefly in one slide to explain the types of impacts it's causing in New Zealand. So these are either direct impacts caused by the feeding of the aphid on its host plant. Those are indicated with the green arrows. And you can see some of kind of the impacts there that we're seeing flowing on from that. The yellow arrows indicate what's impacts that are caused by the honeydew that the aphid secretes. So it secretes vast quantities of this. You get huge colonies in willow trees, and if you stand under a willow tree that's infested, you can even feel this kind of mist raining down on you. And some of you might have seen in Sammy's talk this morning a diagram of an aphid's gut. And so you saw how a lot of water passes through it quickly, but it's still rich in sugar, this honeydew. And so it's a resource that's utilized by honeydew feeding insects, such as pest wasps. And it's new for New Zealand, so not that many years ago, it wasn't a resource that they could use. And since that time, we've seen a real spike in wasp numbers in New Zealand. And if you think about the problems that you know of with wasps associated with beech forests in the South Island, it's a lot like that, just a different insect, different trees. But because we're dealing now with willows and poplars, which are widespread throughout all of New Zealand, it's like taking that problem and bringing it out into the rest of New Zealand. So as beekeepers, I don't need to talk to you much about why wasps are bad, but I would like to point out that there are untold effects on New Zealand's biodiversity that we haven't even categorized yet. Some of you as well may have seen this cement honey when bees gather this honeydew and bring it back to their hives. And also sooty mold grows on anything that's covered with this honeydew. Last year at the conference in Blenheim, we took a survey of beekeepers to try and figure out what this aphid was having, what kind of effects it was having on the beekeeping community in particular. I'll just cover this briefly, starting at the top. So 3/4 of you said you had seen evidence of this crystallized honey, and half of those people said they'd experienced some kind of losses in association. So for example, one person commented that they had some damaged filters and a $3,000 bill for that. Some people have also chosen to take their honey off early because of the risk of this crystallized honey, or to move their hives away from areas with willows. Moving on to wasps, 80% said they saw a greater increase in wasp numbers. And there was one interesting comment I'd like to point out. Someone said, oh, this aphid's not really a problem for me, I'm just hearing about it from other beekeepers. What I have seen is a huge increase in wasps. And I would argue to this person that what they're actually seeing is the effects of giant willow aphid, at least in part. In terms of damage on willows, 61% said they'd seen some kind of damage, blackened stems or branch dieback, and 41 actual death of willows. We've worked with an economist at Scion and come up with a figure of $300 million in economic losses per year, caused at least in part by giant willow aphid. So we used information from things like the New Zealand Colony Loss Survey published last year, some of Trevor's research, some reports from the New Zealand Poplar and Willow Research Trust, and other sources. I don't have time to go into detail here, but I've organized these into groups. So there's different types of things like the effects on willows overall is the biggest factor. Next comes honey losses. So mostly those are effects of pest wasps, but also cement honey comes into it. And there are other wasp impacts. Some of them flow-on effects, such as wasps disrupting bees, which interferes with pollination services, which means less nitrogen is fixed. Sooty mold comes in there as well. This is a big problem for kiwi fruit growers. They can't wash this off their fruit, and all of that fruit is lost. It can't be exported. It tends to be fed to animals. This figure comes from Zespri, and it's only a very small portion of their losses attributed to sooty mold, because the major player there is actually the passion vine hopper, but we know that giant willow aphid plays a role as well. So that sums up GWA is bad. But I'd just like to point out that I keep hearing about new things as well. So this is Nicola. She's a basket weaver down in Nelson. She makes coffins for people. And she's having troubles with the aphid, and I found out that this community tends regularly to spray, and they're also ripping out willows and planting different varieties. So on to our work. We knew right away we wanted to look for a parasitoid, because predators for biological control tend to be too general, and diseases are really hard to work with. So we looked in the literature, and we saw reports of a parasitoid associated with giant willow aphid in parts of the US and Eastern Asia, and we undertook a couple of scouting trips to California and Japan. When we got there, it was really hard to find any giant willow aphids, and so presumably the natural enemies in those locations are doing their job. But we did find some, and we managed to rear parasitoids out of both populations. For various reasons, we chose California as a source for import, and after much work to get it approved to bring into the country, and a lot of help finding it in the field using citizen science, and the help of people like Stephen Siebold of the USDA Forest Service, we managed to get the population here into our containment facility at Scion. So here's Steve looking really as nonchalant as he can with a big ladder in downtown Oakland. That's where the bulk of our parasitoid population came from these tortured willows on the edge of a man-made lake. These are a couple of mummies. So aphid mummies are aphids that have been parasitized. The parasitoid has grown up inside them. They've become kind of puffed up. They don't die until that last point. So they're walking around with the parasitoid larvae growing inside them for a long time. Then finally, they become dead, fixed in place, and the parasitoid goes through a short maturation phase and comes out as an adult, as you can see here. So these are parasitoid wasps. I don't like using that word, but they're classified as a wasp. but they're only 3 or 4 millimeters long. They don't sting people. They're only a risk to aphids. And we think this one is only a risk to giant willow aphid. So in our containment facility, we've been working on these. In the picture there, you can see me releasing for the first time this California parasitoid and introducing it to our New Zealand giant willow aphids, and it's taken to them very well. We've now reared over 4,000 individuals. We're in the 20th generation. And we've been learning about this biology from scratch. So this parasitoid, Poasia nigravirea, was named in 1888, but nobody's ever studied it. So this is all new and fun. So here's a parasitoid approaching a colony of giant willow aphids. Here's a dissected mummy showing that big parasitoid larva that was developing inside its body. And here's a parasitoid adult that's come out in gel caps. So we captured all the mummies in gel caps and reared them individually. You can see how small she is, if that's a gel cap. And we found that at 20 degrees, it takes about 2.5 weeks for them to develop. We also spent some time watching the behavior leading up to attack. So this is a parasitoid that's come up to some aphids. She first checks it out with her antennae. If she likes what she senses, she'll extend the ovipositor underneath and feel around the body of the aphid. If she decides, yep, it's good to oviposit, she does this little kind of happy dance. I'll just demonstrate. After that, you can see the ovipositor comes really quickly away, and we've confirmed through rearing that this is what's happening. She's ovipositing when she does that. So there you see her checking it out, stroking along, looking for a good place to oviposit. Oh, maybe not. Let's see, where's a good space? Oh. And there she goes. Happy dance. Okay. So a big part of our work was deciding which aphids in New Zealand we wanted to test. So we had to make sure this wasn't going to attack anything else in New Zealand. This was really difficult, finding native aphids, finding their host plants, and rearing everything. Every aphid is different. It was a lot of learning. We're really lucky, though, in New Zealand, because the biggest predictor of whether something would be susceptible to this parasitoid is if the aphid was closely related to giant willow aphid. And there's nothing in New Zealand that's closely related to giant willow aphid except for a handful of other exotic aphids. So right away we knew that we were looking good, but we couldn't not test any native aphids. So we tested one species from all of the 4 groups that are present here. There's only 15 native aphids in New Zealand out of 130 aphids here. So we introduced mated females into test cages with GWA as control, and then we did further work with each female to ensure that she was viable. She wasn't a dud for some reason. That did happen, and if so, we threw out any of those replicates. And we checked for mummies over the span of a whole month, just to make sure. So here you can see our host species that we tested on the left. This is the closely related ones, Naraphresiae. And we saw no evidence of parasitism in any of them, so no mummies formed, and of course then no wasps came out. We did some behavioral assays as well, so just looking really closely at what is happening in terms of those antennal contacts, and did she bother to get her ovipositor out and probe the aphid. This is the closely related Cynara. You can see it actually kind of looks like GWA. And here we found a big difference in the behaviors. There's a little bit of ovipositor probing, and this was one single individual that looked like she tried to oviposit, but actually we couldn't find any evidence of that afterwards. This is a distantly related aphid, no attempts at oviposition at all. One, again, tried to feel around with the ovipositor. So we think that we've got something that's highly specific. We feel really confident that it won't harm anything else in New Zealand. The greatest risk to anything would be to any other close relatives, which are all pests. We also think that if we can suppress the population of GWA, we'll therefore have less honeydew in the environment, and this should have a strong impact on reducing our pest wasps, possibly also harlequin ladybirds, because they like to feed on GWA. We're lodging the EPA application tomorrow. We'd really appreciate your support. If you want to come out to a poster session afterwards tonight, you can press a pin to indicate your opinion. You can email me, or when this opens on the EPA website, you can submit a submission formally. And we are planning our next year as we speak. I'll stop there. Thank you. Acknowledgements. Everyone on the left was part of the project team, and this was an SFF grant.